What did you have for breakfast today?
I don't eat breakfast.
Okay. No breakfast at all.
No breakfast at all.
This podcast is brought to you by Neural Media. Are you an entrepreneur or maybe a marketer who wants to grow their business through content production? Maybe you're sick of dealing with agencies or want an outsourced solution that actually fits a budget? Well, Neural Media, our business, can help you with simple and affordable content production, saving you time and money by taking away that pain of producing the content. If you want to learn more, just head to neural.com/media, which is NEURALLE.com/media. Play around with our pricing, have a look at all the different options that you have, request or consider requesting a callback from me personally. If you have a friend that runs a business or is a marketer, do send them our way. It will help us keep the lights on and producing more juicy content. Listeners to this show receive a special discount by using the promo code UNCOMMON. If you want to learn yourself as to how to create content, maybe you want to make a podcast or your very own video, just download our free series on how to create a podcast and video at the very bottom of neural.com/media. Welcome to Uncommon, the podcast that helps you build your knowledge, skills, and mindset through interviews with unique individuals. My name is Jordan Michaelides, the CEO of Neural Media and your host for this podcast. In this episode, I have for you Kyle Berean. Kyle is the Chief Technology Officer of Atmo Biosciences. He's a research fellow at RMIT University and a fellow IBS sufferer. Many of the listeners and readers may already know about my running IBS issues, a gut disorder that I'd like to well and truly put to bed for good. The constant anxiety, nausea, and pain I've suffered from probably since my early 20s is still really unresolved, and it's simply down to the fact that doctors and researchers don't truly understand what's going on inside the mysterious gastrointestinal tract, particularly for these sort of gut or gas-based disorders. Now, this revolutionary piece of science in the form of an electronic pill is so transformative that Kyle, his research colleagues at RMIT and Atmo Biosciences could potentially change my and many other people's lives forever, like permitting that they get through all the necessary regulatory hoops and hurdles. We could know how to fix this general catch-all phrase of IBS for good. And I thought it was my civic duty to get Kyle on the podcast to make gut sufferers out there aware of the work that Kyle and the team at Atmo does, so we can continue to encourage this groundbreaking research in Australia. This was a information-filled chat where we covered a lot in an hour, including IBS, Giardia, and gastro, going from oil to audio to nanomaterials, why the gut and breath tests are largely misunderstood, how the Atmos gut capsule will transform this area, getting the regulatory tick of approval, and Atmo's direct-to-consumer approach. I think this will be very enjoyable for anyone who's liked our previous chats on gut issues or medical topics that's generally on some form of groundbreaking area. If you enjoy this episode, do subscribe on your podcast app or leave us a rating. That will go a long way in helping us grow the podcast. If you want something similar, just check out my chat with Dr. Iggy Susay, episode 71, where we spoke about diseases beginning in the gut. All show notes and previous guests are at neural.com/podcast. It's NEURALLE.com/podcast. But as I say each week, thank you so much for listening, our regulars for coming back, our newbies, thanks for giving us a shot. I hope you'll enjoy this conversation with Dr. Kyle Berean. Kyle, thanks for joining me on this, well, it's a pretty flat day, considering it's summer at the moment.
Yeah, it's beautiful out.
What is it, like 25, 26, something
25
like that?
degrees.
First question for you, I had for you as a fellow IBS sufferer is what's sort of the worst public situation you've been in? Like, for example, people might find this funny, but I've got an app on on my phone. Well, actually, you know what? I don't have it anymore, but it was like public toilet finder or something.
Oh, that's fantastic. Yeah.
Have you ever had any awkward situations like that at all?
No, I'm pretty lucky. My IBS isn't that severe. So I've had issues at work where I've been in meetings and I've felt that need to go to the toilet, but I've never been stuck out at a situation where I couldn't find a toilet quickly.
Yeah. Yeah, it's sort of a cruel twist of fate that while you were starting out to create this pill and this program, that you sort of developed this issue yourself. I was curious, how do you think it came about? Like, I have a belief that it came from gastro for myself.
Yep.
Like a really bad bout of gastro. Do you think there's any connection there at all with how it comes about?
I have no idea of how this thing starts, but I do have a similar story. Traveling through India, getting Giardia, and having multiple bouts of that, multiple rounds of antibiotics, and that's when I started to notice it.
Really?
Yeah.
Yeah, my barber, she had Giardia as well.
Yeah.
She was in Bali or somewhere like that. Like maybe it was Thailand, sort of along like this river that people often go like clubbing and all that sort of stuff. And she reckons that she caught it there, and obviously she had it, and they dose you pretty heavily with antibiotics, right?
Very, very heavily, yeah. It's like napalm your entire body.
Exactly. And see, I had the gastro. I didn't take antibiotics, but I didn't take any sort of probiotic during it or like, at the same time. And it's so funny because I was telling you before, and our listeners will know that I've done the FMT.
Yeah.
During that FMT process, the last week I got gastro. And so I had one more FMT to do out of 10. And what was super fascinating is I decided, like, I was still really sick after a week. Like, I was just run down. And I thought, you know what, I'm just going to see what the FMT does while you have this. And it was like an immediate impact on my gut.
Okay.
Yeah, it was amazing. And I did another 2 or 3 FMTs after that. That definitely, I think it definitely does help. Like, it just introduces new species. But the problem is that you need to eat certain foods to make sure they survive.
Well, I mean, the problem for me with the FMTs is, where are they getting it? Like, how do you actually, how do you identify the best donors? And, you have to go through that process to see who these super donors are, so you can continually go back to them to get these strains that you're after.
Yeah, and they'd have to, like, how that would impact their lives so much as well, because they've got to go to the bathroom, they've got to collect the sample, make sure it's stored properly.
Yes.
Give it to, you've got to hope that they live locally.
Yeah, that's right.
I don't know what they get. They must get paid like, I remember hearing like $100 per sample or something like that.
That does not seem like enough.
You reckon?
Well, I bet you've probably sampled your stool many times, as I have during this process. It is not fun.
Yeah,
right?
It's not fun at all. And each FMT is like $400. So I don't know. It's intriguing. I reckon it's probably 100 to 150, which doesn't sound like a lot considering what you have to do.
Well, and what's the clinician getting?
Yeah, the rest of it.
Yeah.
Those things, like, I got to say, those things are brilliant factories for supplements and whatnot.
Yes.
When I was looking at all this in my notes, and I found it really fascinating, like, your background, because you started with audio, right?
Well, yeah, absolutely, yes. I don't know how. Actually, I started on oil rigs.
Really?
Yeah, I finished finished high school, went to Melbourne University, did a basic science degree, failed everything in the first 6 months, dropped out, moved over to the UK and worked on oil rigs in the North Sea.
You're kidding?
And then I realized that that's absolutely not what I wanted to do with my life. So I came back to Australia and I studied audio engineering.
Yeah, so you did audio engineering, you did your bachelor's, and then you pivoted. No, you're an audio-visual technician running your own business.
Yes.
Yeah? And then you sort of pivoted into this area, and eventually you've done this PhD in what is it called? Nanometrics or
nanomaterials.
Nanomaterials.
So it's a material science PhD. Based around gas permeable membranes.
Okay.
Yeah.
How did that all come about? Like, I know that you, the how I found it was on your LinkedIn profile. You spoke about your career prior as a technician.
Yeah.
And I was, you must have been soldering things together and all that sort of stuff, because I know dealing with audio and visual equipment, it can get a bit like that.
Yes.
Is that how you got this interest? Like, where did you go? All right, I'm going to go to RMIT and I'm going to do a PhD in nanomaterials.
Well, so I realized that I needed an electrical engineering degree to do what I wanted to do. So I was soldering stuff with audio. I loved the signal processing within audio. I loved that electrical flow pathways. And so I went back and I did electronic engineering at RMIT. And one of my professors in my undergrad, he asked me to do a PhD with him. And one of the projects that he pitched to me at the time was developing a capsule that monitors gas production within ruminants. Right. So we wanted to understand what carbon dioxide and methane emissions there were within cattle while they're grazing in the field. To try to help breed lower emitting animals. And we were given money by the government at the time, leading up to the carbon tax, to try for them to know appropriate tax rates to put on farmers. And then and then during that process, you had the changeover of the government, and all of a sudden we didn't believe in climate change and we scrapped the carbon tax. And so all of our funding went out the window, and we pivoted to what actually was my professor's original idea, which was to use that same mechanism, using the gases as biomarkers to understand the microbial groups that live inside of your body. And we were focusing on human health after that.
Yeah, I remember. How do you pronounce that professor's name?
Professor Kourosh Kalantar-Zadeh.
Zadeh, that's it.
Iranian.
Iranian, yeah, because he's an interesting character, because he was the guy who sort of pivoted, or at least thought of, instead of measuring that external element of the gases, measuring things internally, right?
Internally, that's right.
Yeah, it's sort of a complete inversion of what was standard at the time. It's funny reading about that and how you guys pivoted all of that into this little thing, which is now a fledgling company in a way.
That's right.
I wanted to just touch again on that personal element, because we were chatting before, and I've had IBS and what we believe is SIBO, as well as this sort of visceral hypersensitivity, and they know it's sort of that because if I drink like hot things like this, I'll have sensations because of that. I've been to gastroenterologists who don't believe in IBS and all these sort of things, right?
Yes.
I've had numerous colonoscopies, and I just really, like, it stood out to me when you guys were talking about how this is sort of not pseudoscience, but the way to measure things in this area is there's just nothing really there.
It's really shocking, actually. When we started working in this field, we were absolutely shocked with how much in its infancy the knowledge around the pathogenesis of all of these disorders, and even the arguments that take place at conferences around small intestinal bacterial overgrowth, or SIBO, or IBS, and how you actually treat IBS, and how you label IBS, because IBS is a disorder, right? It's not a disease. It's kind of a catch-all where you have IBS, diarrhea, you have IBS constipation, and how can they be the same thing? And then you have IBS mixed, right? Which is you're either constipated or you have diarrhea, mixing between the two. And then there's IBS undefined. And that's how, if you're in that group, you're good luck, because they don't understand the ones that they understand.
Well, you also get doctors who think IBD and IBS are the same thing.
They have absolutely no idea what they're talking about there.
So I think that really, to me, highlights how transformative this pill and this idea is, particularly around identifying the problems. And I just wanted you to explain. Right now, I think most people would know from previous interviews I've had, but basically the only way to measure IBS is you do these gas tests,
Yes.
like a breath test. So you drink something and then you measure that over a period of 3 hours or something like that.
Yeah.
So why in these tests is it only got, I think you highlighted in one interview, like a 70% accuracy, but there's lots of false negatives and positives.
Yes.
Why is that? Well, how does it work?
Okay, so how it works, let's start there, right? So there's a whole bunch of conditioning that you have to do prior to doing these breath tests.
Yeah.
So you have to basically flatline all gas production within your gastrointestinal tract.
Yeah.
To try to understand what your baseline is. Then you give a substrate challenge. So you're challenging those bacterial communities within your gut with one specific substrate.
Okay.
And as it's traveling through your gut, the microbial groups are fermenting it. So they're using it as their only food source, or not their only food source, but their main food source, and they're creating gas. So that gas is created within the gut. It's transferred across the epithelial wall into the bloodstream, circulated around the blood and into your lungs, and then transitions into your breath. And so each one of those stages has a time constant associated with it, and each one of those stages has a dilution factor associated with it. So trying to then look at both the quantity of gas that you're produced in your breath and the timing of when it's produced in your breath with reference to when you ingested that sugar load is a little bit hand wavy. So they say, you know, if you've gone over 10 parts per million of gas production, you know, before 30 minutes or 50 minutes, I can't remember what the threshold of diagnostic is off the top of my head. They're saying that, well, that's a sign of an early rise in hydrogen production. So therefore you have the wrong bacteria in the wrong place within your small intestine. However, when you actually go a little bit deeper into the science and you start to challenge that idea, which a lot of scientists have done, where they've radio-labeled or they've put a radionuclide on that carbohydrate to try to take nuclear medicine or CT scans of
while they're doing it.
While they're doing it, to try to understand where these sugars are in your body whilst they're being fermented. And one of the problems is when you give somebody a challenge of a single carbohydrate, each carbohydrate has a different effect on transit and motility. So specific carbohydrates will hasten transit. So lactulose, which is the main one for SIBO, will hasten transit. So through an osmotic effect, it will already be in the colon, fermenting within the colon early enough to cause that early rise within the hydrogen production within your breath, and so therefore giving you a false positive. Yeah.
Wow. And so what your pill does, maybe you can explain your pill and how that changes that, because it seems like you're taking away the need to do the CT scan, because now you can just measure that via Bluetooth onto your phone with this device. Yeah. And you can also just eat normally. Yes. And measure things that way.
So our capsule, what we've made is just an electronic pill the size of a vitamin pill, large fish oil capsule, that as it transits through your gastrointestinal tract is measuring numerous gases: hydrogen, carbon dioxide, methane, and importantly, we measure oxygen. So we use oxygen as a location marker. So we see a huge drop in oxygen as you transit out of your stomach and into your small bowel. And as it transits from your small bowel through the ileocecal valve into your large bowel, you'll see another drop within that oxygen profile. So we can tell which organ it is. And as we're telling which organ it is, we're monitoring the gases that are produced within that organ. So if you wanted to test for, say, small intestinal bacterial overgrowth, and you want to see, well, do we have too much or too many bacteria proximally within the small bowel, or too early within the small bowel, then you're looking for that hydrogen production just after the gastric emptying event.
Right.
And so we're looking to expand on these analytes that we're measuring at the moment. We're looking to open it up to hydrogen sulfide, which is a really interesting gas because it's very important, what they call a gasotransmitter. So the microbiome uses this gas to send signals out to the rest of the microbial groups to tell them what to do. But it's also an indication of inflammation. Well, it's actually a little bit more important than that. It's not just an indication of inflammation, it can cause inflammation when it gets above a certain level, but it can also reduce inflammation if it's within the right band. It's a very complicated area, but we're also looking at some short-chain fatty acids like acetate, propionate, and butyrate, which, again, are extraordinarily important for the health of the gastrointestinal walls. So butyrate is anti-inflammatory, it has anti-carcinogenic effects, and so there's a lot of functional food groups out there, probiotic groups, prebiotic groups that are trying to get inulin into your large bowel. However, they don't have any science of whether it's all being formed in the start of your large bowel or just within the colon itself, because to have its anti-carcinogenic effect, it has to be distributed evenly throughout the entire large bowel. And so we're hoping to shed some light on that, how that system actually works, and to try to help people find the right foods for their diet to actually, make sure that they're not going to develop cancer in the future.
Yeah. And
then also to try to diagnose specific diseases and disorders like ulcerative colitis or IBS or small intestinal bacterial overgrowth.
And actually understanding what IBS is. That's the key thing, I think.
I think that's a very tall order.
Yeah.
We'd like to play a role in that. I'm definitely not setting out thinking that we're going to reinvent the wheel, but we'll hopefully be a part of the generation that helps to understand that area a little bit more.
Well, it had me thinking when I was doing my research, like you obviously suffer from this. Have you been able to partake in any of the studies yourself?
So unfortunately, to date, we've only had ethics approval to do it on healthy subjects. Uh-huh. So I'm not...
Really?
Yeah. So we've just transitioned out and we've started to ramp up to raise money to be able to do clinical trials in people with SIBO, people with IBS, each different phenotype of IBS. And so I personally have not taken it yet, but I will be within the first group of disease patients.
Wow.
Yes.
Yeah, because it just had me thinking about what has this taught you about how to you've measured these healthy people. Mm-hmm. What has it taught you about how to treat yourself, at least with the information that you currently have? Because some of the things that you guys learned in this research was very interesting. Like the thing you've mentioned a few times, like the oxygen levels in the colon, mm-hmm. Food staying in the digestive tract too long and causing a sort of immune response in a way.
Yep.
And the impact particularly of fiber on the gut.
Yes.
So how has it changed the way that you approach your IBS?
Well, it's made me really start to have a bit more of a balanced diet, because I've seen some of the byproducts that are created if you have like a full meat diet, or you don't have enough fiber, or you have just all legume diet where your fiber intake is through the roof. Yeah. And neither of those things are particularly healthy. We saw within our extreme high fiber case where they ate nothing but legumes pretty much, and they had a high amount of oxygen within their colon, and that is not very good at all. So that area is meant to be anaerobic. It's meant to have no oxygen around. The bacteria in that area die if they come into contact with too much oxygen.
Really?
And so you don't want to flush out that microbiome that you've been creating and cultivating your entire life, right? You want to try to keep it in a good place.
Yeah, so you don't have too much meat, you don't have too much carbohydrates.
Yeah.
You make sure that you have a decent amount of veggies that don't have too much fructose in it.
Exactly.
And still a decent amount of fat, but not too much as well.
Yeah.
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 Yeah, because I was talking about this with my partner last night. She's like, it's just the old adage, like a balanced diet really works. You look at places like those blue zones. I've read, what's that book from the Longevity Institute? This researcher, Dr. Walter Lungo.
Okay.
This one here, the longevity diet.
The longevity diet.
Yeah, he studied those blue zones, and there was a few others that he encompassed as well. And he also mapped out things like how the change in diet in places like Okinawa, which is one of these blue zones, had affected the younger generations because they'd taken on a more American diet.
Yep.
Or elements of more American diets. And so, yeah, just although he was sort of preaching more, not veganism, but like vegetarianism, which I was suspect of a few things. But yeah, I think it just, a lot of that holds true. Like you just got to have that balanced diet. Eat where your ancestors are from as well, which is one thing that he's spoken about. So like if you grew up, so my dad's family's from Cyprus, which is an island. They eat lots of seafood and fish and stuff like that. Make sure you have some of that on a weekly basis if you can.
Yep.
And then mother's family is from sort of a coastal region as well. And so you try and eat what you can where they grew up. And so it's interesting.
Yeah. And it's also interesting reading the papers about, development in your early life and the development of the microbiome in your early life, specifically within the first 5 months of your life, because that's really where the groundwork is put in on what your microbiome makeup actually looks like. And a lot of that is, unfortunately, it's about how you're born. Are you C-section or vaginal birth? Are you breastfeeding, or are you having formula that's been sterilized? How much sterilization are people putting on your dummy? And, all of this stuff actually plays a big role in setting up that microbiome for your later life.
Yeah. Well, my current GP, who's specifically looked at the SIBO issues, believes that me having, tonsillitis for like 6 years in a row, annually.
Yep.
And the amount of antibiotics I would, because he looked at my entire history.
Yep.
Would have definitely impacted my susceptibility for getting these sort of issues, he believes.
Yeah.
So it's interesting. I know we were chatting before about this. So you were saying that you believe that the approach of just looking at the biome, like, just these strains being in these ranges is like the optimal way to live, is potentially the wrong way to think about it.
Yeah. The way I think about it is you can't identify a specific strain or multiples of strains that are always helpful, always beneficial, because you put them in different microbial communities and all of a sudden they don't act in the same way. I have no examples off the top of my head, but I think we're holding too close a microscope on this thing, because so
it's sort of like a trend topic and people are just going nuts.
Yeah, absolutely. Everybody is getting in at that atomic level. Let's look at how these atoms are actually put together, where you actually have to take a step back and what is the interaction between these microbial groups, because they're all, you have different layers of metabolism here where you're giving your substrate and they're being fermented or they're being metabolized by one group of bacteria, created byproducts for the next group of bacteria, byproducts for the next group of bacteria. And so the byproducts that are created are the things that are giving you your sensitivity issues, that are giving you the inflammation within the bowel. It's not this specific to that bacterial strain. It's the byproduct that's created by it.
Yeah.
And so there are certain situations in which communities with, healthy or good bacteria for you that are creating bad byproducts.
Yeah. Now, the pill itself, one big question I had was, how does this thing measure It sits within a casing. So
Yep.
how does it actually measure this stuff when it's in there?
Yeah. So this was actually the subject of my PhD.
Really?
Yeah. So I did my PhD on gas permeable membranes. And so
that's right.
So we have one section of the capsule that's got a gas permeable membrane that allows the gases and other volatiles to penetrate into the capsule, so we can measure them, but doesn't allow the acidic liquids of the stomach or some of the fecal matter or the any of the liquids within the gastrointestinal tract to actually penetrate into the electronics.
Huh. And so what is that membrane made out of? Like, this goes to that sort of at that nano level, but
yes,
what is it made out of exactly?
Well, I don't know if I want to go too deep into it.
True, good point.
But I mean, you could read my thesis to get a general understanding of how these things work. But it has a backbone of a thing called polydimethyl siloxane.
Mm-hmm.
It's a rubbery polymer. It's basically a silicone. So very similar to what is the sealant on your windows. Very similar to actually the exact same polymer that McDonald's puts into their French fries. I don't know if you knew that, but McDonald's puts PDMS within its French fries.
What?
Yes.
That's a bit of a worry. Jesus Christ.
Yeah, I think to hold it together or something like that.
Wow.
Yeah.
Where is it made? Like, because one of the things I noticed is the medtech pharmaceutical space here in Melbourne is very proud of you guys. Or at least when that release came out, they're like, "Oh, look at how good our scene is," and blah blah blah. Which they've got a point. But I was curious: is it manufactured locally? When you did the original trial of like 26 people or something?
23.
Like 23.
Yeah.
Where was it made?
It was all. We got our PCBs, printed circuit boards, made in New Zealand.
Okay.
But all of the fabrication was done in Melbourne at RMIT.
In the space.
In the space by a very talented engineer of ours, Mr. Nam Ha. He is the developer, and he has designed all the electronics of the capsule. Mm-hmm. Extraordinarily talented, and he has the smallest hands and steadiest hands that is able to solder these things. I've never seen anybody do it like him. Really amazing. And he's been able to incorporate my membrane design and fabrication into his electronic structure.
Right, and so that combined gives you this pill.
Yeah.
Are they easy to swallow? I know I struggle with swallowing things, but are they monster pills or?
We've never had a problem with people swallowing it.
Okay.
With the. It is visually daunting. It's the size of a fish oil tablet. I think that's visually daunting.
Yeah.
But we haven't had any issues. And we've been talking to some pediatric gastroenterologists that are interested in using it in trials for children to the age of 12, down to the age of 12. So they don't see a problem with that size of swallowing it.
And where does sort of the development and iteration go from here? Like, obviously you've got... What you really need to do now is trial it on larger groups of people, which is obviously part of this commercialization and the capital raise.
Yep.
What else needs to happen? Is it, making the pill smaller or bigger, or so you can fit more things in there, or like you said, measuring of more things? Where does it sort of go over the next few years for that launch of, or idealistic launch of 21, 22?
Yeah. So we have nailed down clinical indications that we're going after. Mm-hmm. So, I mean, when you're talking about actually being used as a diagnostic tool, there are a lot of regulatory hurdles that you have to get over. Now, we've been a university project until the end of last year, the start of this year, where we've spun out this company. We're doing a capital raise at the moment, and part of that raise is about developing the technology under what's called a certified quality management system, and that's to then take all of these certified documentation to your regulatory body, TGA, FDA, or the CE mark in Europe,
yeah.
and to allow them to give you the tick of approval for you to go and sell your device.
Right.
And so being able to prove specific things within each clinical indication is very critical. So a really low clinical hanging fruit for us, a clinical indication, is motility and transit time. So just tracking how it's moving through your body. There is a predicate device on the market. It's the Smart Pill. It's made by Medtronic, and it measures pH. So that's just looking at how is it transiting through your body, nothing more. And so we're going to piggyback on that to get into the market, right? And so that's a very low hanging fruit in terms of the amount of clinical data we'll need to show, because all we have to show is, okay, it's transiting from this organ into this organ. And so we're doing gastric emptying time, small bowel transit time, large bowel transit time, and total transit time. Right. So as long as we're able to show those things consistently and safely, compared to a predicate device, then we're going to get that tick of approval to move forward.
And so when you do this sort of stuff to get that tick of approval, let's say with this pill, you just want to show that motility element. Is that all you're allowed to advertise the device when you're eventually selling it for? Or can you go and include other elements, or do you have to do next rounds of testing to show that?
Yeah, so you are definitely not able to advertise for off-label use. If it's been indicated for motility and transit time, then you can't be advertising it for SIBO.
Okay.
But if you can show that these other gases that we're measuring, not just oxygen, but the other gases, so hydrogen, methane, and carbon dioxide, are important within that motility sphere, then we're able to report on those gases. Right? So we're not able to advertise for off-label use, but that doesn't stop people using it off-label.
Okay. Wow. And, I thought about the business model and all. This is a huge addressable market. I just thought about look at all the people who could potentially do this or do colonoscopies each year, and then multiply that out by people who need to do it multiple years, and each is it's just a massive market. So
IBS is the largest indicated chronic disorder or disease in the United States.
I'm not surprised by that. Yeah,
it's huge.
And do you guys want direct access to the consumer, or how do you want it to be? Because you're sort of building this system where it's both an app where you can look at things on your phone, right?
Yeah, so at the moment, we're really focusing on that diagnostic prescription pathway. So we're starting off where that phone is really just an indicator for the patient whether the capsule is still in the body and the test is taking place, or if it's come out.
Okay.
So eventually, once the science is a little bit more sound, once we have a better indication of what the outcomes are by our readings, then we'll start to look at a direct-to-consumer approach.
Okay.
Because we do want to empower the consumer. We do want people to be able to test their diet and how is that actually directly affecting these microbial groups and the byproducts therefore created by these microbial groups. But we really need to make sure that we have the scientific backing to give those claims across.
Yeah, and I know, from your perspective, obviously someone who suffers from this, you want to be able to get it out there as soon as possible,
yes.
But you've got to do it the right way.
The right way,
yeah.
Absolutely. We first and foremost, we want to make sure we're not going to hurt people, and then we want to make sure that we're not just going to be another snake oil salesman that gives you this device at $500 a pop, and then pockets the money and gives you some little feel good story about, oh yeah, you should definitely eat more rounded and healthy diet. Done.
Yeah. Yeah. Look, I've got a brother who's type 1 diabetic, and he knows it's sort of cruel how expensive a lot of that equipment can be. Yes. I know a lot of it's covered by Medicare and all that, but still, it's sort of they need it to basically live, and these companies have got like a real stranglehold on this thing.
Yeah.
So it's going to be interesting to see how this pans out. With Atmo itself, how did this sort of come about? Like, why did you guys go together and just say, well, we're going to found this company and we're going to commercialize it? Like, who led the way there amongst the team?
Well, I think that was a reaction to the stage that we are at. So
Okay.
Government grants and those ARC and HMRC grants are really good at helping you develop that fundamental science of it.
Mm-hmm.
However, when you start getting to a point, they want to see that there's at least matched funds from industry. So you either have to go out and partner with an industry group that's already established, or you have to create that group.
Mm-hmm.
And so we were in discussions with numerous potential partners, and we felt that we were probably better off by making our own entity and moving it forward that way.
Mm-hmm.
Yeah. So we're right now we're right in that the valley of death, as they call it within tech dev, right, or med tech dev, where we've done our initial clinical trials, we've done all of that grant funding, and now we're trying to step out and bridge the gap until we have all of the clinical data we need for a reg submission and getting to market. And we're just in that stage now where it's high enough risk to be unattractive to certain potential investors, but we've got such potential that people who have the deep pockets and see the potential and they're putting some money into it.
Yeah, it's very interesting with this stage. Like, it's just so different to most other tech businesses, because if it was a software business, you just raise the money and 4 months later you've got some working product. But with this, because it's a more, like, the market is bigger, obviously, than your standard like software as a service company for pet stores. Like, this is a very big thing. So obviously there's a lot of infrastructure, a lot of work that has to go into it. Are you still working as a research fellow at RMIT? Like, do you split your time between the two?
No, so I'm solely CTO of Atmo Biosciences. Mm-hmm. I have a adjunct appointment at RMIT. So RMIT wants to continue to support the work that we do. So we do a lot of development and testing still within the labs at RMIT. So we're working in lockstep with RMIT on this one. Our professor, who is one of the initial inventors of this device, Professor Kourosh Kalantazadeh, he's moved to University of New South Wales. So I also have an adjunct appointment at University of New South Wales, where we have an HMRC grant where we're trying to develop that short-chain fatty acid sensing. Yeah, so I've got numerous research parts of my job, but my core focus is on the product development and getting it into our own pilot clinical trials that we have coming up.
What does an adjunct fellow do? Are you sort of there on a casual basis doing very specific research? Is that sort of how it works?
So there are numerous ways that an adjunct appointment works, but essentially my adjunct appointment at RMIT means that I still have access to the labs. I still have access to all of the research database, so I can continue to research or read up on what the latest research is. And so RMIT gets some benefits out of this. If I publish any new articles, I still have that affiliation. RMIT still has their badge that, this product was spun out of RMIT and now is within Atmo Biosciences.
That's it's like brilliant advertising for them.
Absolutely.
If a company can be formed from this, it's sort of the next wave of people intrigued by this area.
Absolutely.
It looks fantastic.
Yeah, it's a great, stamp of approval for the university, and I know that RMIT has worked really hard at trying to differentiate itself as an entrepreneurial university, and unfortunately there has been setbacks within that where a lot of the tech hasn't been able to get out, but we managed to do it. And I think this is across the board in Australian universities that spin outs or tech transfer from IP developed at a university isn't always the easiest. You look at the United States, MIT, Stanford, and they've got such clear pathways of how they spin out tech. In Australia, we just don't have that.
What do you think is the major difference there?
There's a lot of differences there, but one of the main ones is the supporting industry and supporting funds. So
capital,
right? Yeah. It's all about capital. So Stanford, where's that located? Well, right next to Silicon Valley, where there are people waiting to throw money at you as soon as you come out the door with some new tech. So we're a little bit hard done by that way in Australia, where we don't quite have the people with the pockets as deep as they do in the States.
Yeah, it's something that I was funnily enough thinking about last night when I was looking at what's best, to bootstrap a business or to raise money. And in instances like this where you're building key infrastructure, I think capital you absolutely need.
You need.
Yeah.
And also because there are such stringent requirements by the reg bodies that we have so much documentation that needs to be put in place, and you need to be accredited under this quality management system, which it requires capital to do. And
because you got to pay lawyers or specialists to help do the application.
Absolutely. And then you're constantly audited, and so it's a process. And I think bootstrapping, if you can, in medtech is hard, but there are lots of instances of it. There's a really great medtech company out of Melbourne here, Seer Medical.
Okay.
They came through the Ant Health program with us.
How do you spell that?
SEER, Seer.
Okay. Yeah.
They are an epilepsy monitoring hardware and software backend. Okay. And so they came out of Melbourne University, developed tech, and they've managed to bootstrap this company together. And I tell you what, they're just going great guns. They're started in Melbourne only 2 years ago, I believe, and they're already operating in 4 different states and out of like 6 different hospitals. It's fantastic.
Yeah, well, look, we've interviewed a few people from this space now, like the guys at ClinicCloud, and they've also formed a new company now called CC Labs .ai, which is sort of wetware as a service, like neuroscience wetware. So you can hire neurons to do experiments on at whatever, how many hours, days you want, which is super interesting.
That is.
So yeah, I think there's actually quite a lot happening here. I've been surprised as we've got into this area and sort of tried to interview people and talk to them about different things. The interesting thing is sometimes when you email professors, maybe they focus on something like CRISPR-Cas9, and I reckon they're so busy, like they don't even respond. You've just got to constantly hit them up like 10 different times because there's just so much going on here.
Absolutely. And if you had emailed us in January, February of 2018, you would have been lost in the sea of emails that we were getting. We were getting, me personally, out of our Nature Electronics paper that came out, and the subsequent media release that came out after that, we were getting 20 to 30 emails a day from patients that are suffering. Yeah. And then you have the media inquiries, and then you have people trying to set up collaborations with you. And it was overwhelming. Yeah.
I mean, I looked at Google Scholar. I've sort of fallen into this space of Google Scholar. It's super fascinating how this is sort of like the thing, if we in media look at like Twitter pages, people in this research space are all about like Google Scholar pages, and I was just like looking at the amount of times you guys have been referenced just goes off the charts in 2018, and particularly your colleague Professor Kurosh or Kuresh?
Kurosh. Yeah.
Just the amount of times his work has been referenced is just going parabolic almost.
Yeah, I mean, Kurosh is one of those researchers who is able to make major strides in quite varied fields. So he had he was a part of a science paper that came out in late 2018 or mid 2018 around liquid metal, an exfoliation of two-dimensional materials out of liquid metals. And so, when you compare that to making medtech, it's a little bit different, and I think that just shows you how varied some of these professors, especially him, the work that they work on is.
Yeah. I'd love to get him in and interview him when he's here in Melbourne next.
He's an interesting fellow.
He certainly seems like it. Now, I know we've got a hard stop, so I've got some short, fast questions to finish off.
Okay, let's do it.
What does your morning routine look like?
So my morning routine is snooze my alarm many times until I panic and have to make it out the door very quickly. It generally involves me feeding the dogs.
Yeah. What breed?
I have a greyhound and a chocolate Labrador. Mm-hmm. And we have 2 cats, so I have to feed the cats as well and make sure all the water is topped up. And then finally manicure my beard.
Okay, of course.
And then make it out the door.
Yeah.
Yeah.
What does your evening routine look like? How do you decompress at night?
Yeah, so that's just about, being together with my partner and cooking dinner together and making sure that we eat that meal and discuss our day.
Yeah. Okay. Best purchase under $200?
Oh, that's tough. I think it's... Okay, so I do a lot of hiking. Okay. So it's this Inline water filter for my bladder, my water bladder. So it allows me not to use those disgusting... purification tablets.
Okay.
Yeah.
So if you're out there, you can go grab some water and just put it through this filter.
Yeah, that's right. So it just is in line from my bladder to my mouth, so I could just suck it through like normally.
Wow.
Yeah, it's great.
There you go.
Yeah. And that was only $30, by the way.
Jeez.
That's fantastic.
That's pretty good. Last question for you. If you had to choose a book for the audience for Christmas, I know we've just passed, but coming up to next Christmas, what would that book be and why?
That's a good question. Look, I probably should be telling you some, healthy gut book that you should go and read, but I tend to try to not read a lot of those books. I try to read the papers that sort of inform those books. Mm-hmm. So I haven't actually read a lot of them.
Okay.
So what I would recommend you to read is 1984 Orson Welles, because it's all happening.
Yeah, it is all happening.
Yeah.
Yeah, that whole stuff in the tech scene right now, and just... It's super fascinating. I've been speaking to a lot of guests about that. We've got a lot of comedians that come on.
Yeah.
And just some of the things that happen, and this is why I sort of work in the crypto space as well, because part of media is censorship.
Oh, absolutely.
And crypto, you can't censor at all. So to
we
experiment
need a crypto
with that,
media.
Yeah, well, there's something called Steam It, which is probably the leading one at the moment, but a former guest from Spot and Inkle. So Inkle is like a media sort of app that allows you to use many subscriptions like New York Times, Atlantic, etc.
Yep.
They've created something that completely fixes a lot of these censorship issues, but also how journalists and so forth get paid.
Okay. So just informing you on how they're getting paid?
Well, they've created a white paper for a new cryptocurrency.
Okay.
And it sort of supersedes all of the current specific currencies related to this space.
Yeah.
But they're going to take about a year or so to launch it. It's called Spot. So
sounds interesting.
Yeah, that whole space is very interesting, and I completely agree. Even censorship on things like Patreon is very scary, and I think people should definitely have a look at that. that's been one of the most interesting things in the last month or so.
Right. Okay.
Anyway, I know we've got to stop. You've got to get out of here. But look, thanks for coming in.
Thanks for having me.
I think what you guys are up to is super interesting. Obviously, you're in that process of raising capital. So I think maybe where could people find you guys? Is it on the website, social media?
Our website. We aren't very active on social media.
Okay.
We have a Twitter page, but we are definitely not active. Hit us up through our website, info, or our email, info@atmobiosciences.com, or our website, atmobiosciences.com.
Yeah, and we'll make sure we link all of that. But thanks for coming in.
Thank you very much for having me.
Cheers.
Cheers.
Thank you for making it to the end. Before you run off, we need your help to grow this audience. Subscribe on your podcast app. Subscribing will give you priority access and help your fellow-minded listeners find Uncommon, or consider sharing this with a friend who you think would enjoy these sorts of episodes, and this will go a very, very long way in helping us build the audience. Don't forget to like us on Facebook and Twitter, or consider subscribing on YouTube as well. You just need to search for Neurale, Neurale, or consider following us on Instagram as well by searching Uncommon, UNCOMMON. But until next time, thank you so much for listening.